Welcome, my dear students. We are going to study types of ligands. Ligand, the molecules or ions which possesses lone pair of electrons are called ligands. They donate lone pair of electrons to the metal atom and form coordinate covalent bonds. Molecules or ions which have at least one atom which can donate a pair of electrons to the metal atom or ion and form a coordinate bond with it are called ligands. The neutral molecules or ions which are attached to or coordinated to the central metal atom or ion in a coordination compound are called ligands. In K4 Ephesians 6, the six cyanide ions are linked to or coordinated to the Fe+2 ion and hence ligand coordinated to Fe+2 by donating lone pair of electrons. Similarly, 4 carbonyl molecules in nickel tetracarbonyl are also ligands, while in CO NH3 Cl2 in bracket Cl, the 4 ammonia molecules and the 2 chloride ions are the ligands. Ligands can be negative ions, positive ions in bracket less common, or neutral molecules. Some common ligands, the negative ions, some of which the unidentate ligands. The negative ions: cyanide, nitrite, hydroxide, nitrate, fluoride, chloride, bromide, oxide, iodide, acetate, oxalate, sulfato, thiosulfate, thiocyanide, isothiocyanide. Then the named as Cn minus cyano, NO2 minus nitro, OH minus hydroxo, NO3 minus nitrato, F minus fluoro, Cl minus chloro, I minus iodo, Br minus bromo, O2 minus oxo, H minus hydrido, CH3COO minus acetate, C2O4 twice minus oxalato, SO4 2 minus sulfato, S2O3 2 minus thiosulfato, SCl minus thiocyanato, NCS minus isothianecyto, ONO minus nitrato, O2 2 minus peroxo, SO3 2 minus sulfato, CO3 2 minus carbanato, NH2 minus amido, SO3 2 minus sulfito, O2 minus oxo, O2 2 minus peroxo. Then the positive ions or the ligands: NO plus nitrosilium, N2H5 plus hydrogenium. Then neutral molecules: CO, carbon monoxide, then carbonyl, ammonia NH3 amino, water H2O aqua or aquo, NH2OH hydroxyl amine, CH3NH2 methyl amine, NO nitrosyl, then NH2NH2 hydrazine, C5H5N pyridine, EN ethylene diamine, then PPS3 triphenyl phosphine. Ethylene diamine, it is a bidentate ligand. CH3NH2 methylamine. Ligands can be classified on the basis of number of donor atoms in the ligand, that is the denticity. First, a monodentate or unidentate ligand. The ligand molecule or ion which has only one donor atom or one point of attachment and can coordinate with the metal ion at any one site in a complex is called monodentate or unidentate ligand. Dentate means tooth. For example, ammonia, abbreviation amine, then water, aquo. The NH3 molecule has only one donor atom, that is nitrogen atom, hence it can be linked to the metal of a complex only through an atom. Hence, it is a monodentate ligand. Other examples are Cl minus, Br minus, I minus, OH minus, S2, etc., which contain only one atom, so it is a monodentate ligand. Other class, that is a poly or multi dentate ligands. The ligand, a molecule or ion which has two or more donor atoms or points of attachment and can be linked to the same metal in a complex at two or more sites is called polydentate or multidentate ligand. Polydentate ligand uses more than one atom per ligand as donor atom. This type of ligand forms a ring structure in the complex. Such complex compounds with the polydentate ligands involving ring structures are called metal chelates and ligand as chelate ligands, and the process of forming metal chelate is called chelation. From the Greek word chili means a crab's claw. When a polydentate or chelating ligand has two points of attachment, it is known as a bidentate ligand. Similarly, one may have tridentate, tetradentate, pentadentate, hexadentate, etc. Ligands which have 3, 4, 5, 6, etc. point of attachment respectively. Point of attachment with the ligands. Depending on number of donor atoms, polydentate ligands are further classified as follows. That is the bidentate ligand, one in which such a type of ligand has two donor atoms in the molecule or ion. It forms two coordinate covalent bonds with a cation. Example, ethylene diamine, oxalate, ox, then carbonate ion, glycinato. Other is dimethyl glycamato, DMG, acetyl acetonate, SASE. The ethylene diamine EN molecule has two nitrogen atoms, that is 2 points of attachment with the metal ion, where each nitrogen atom can donate a pair of electrons. In Cu En twice in bracket 2 plus each ethylene diamine molecule forms two coordinate bonds with a copper ion forming a heterocyclic ring. Hence, ethylene diamine is a bidentate ligand. Another class, that is a tridentate ligand. Such a type of ligand molecule has three donor atoms or three sites of attachment. Example, diethylene triamine, diene. Then 2 double dash terpyridine, म्हणजे TARPY, terpy. Then diethylene triamine, diene, DIEN. These are the examples of tridentate ligands. Then the tetradentate or a quadridentate ligand. Such a ligand molecule has four donor atoms. For example, triene, triethylene, tetramine. Another example, nitrito triacetate, nitrilo triacetato. Then quinquedentate ligands. Example, tetraethylene, pentamine, tetraene. Another type, that is the hexadentate ligand. Such a ligand molecule has 6 donor atoms. For example, ethylene diamine tetraacetate ion, EDTA. Then another class, that is ambidentate ligand. A ligand molecule or ion which has 2 or more donor atoms. However, in forming complexes, only one donor atom is linked to the metal atom at a given time is called as ambidentate ligand. For example, NO2 minus group has two donor atoms, nitrogen and oxygen, but only one N or O donor atom is linked to the metal at a given time at metal M bond ONO or M bond NO2. M bond ONO is a nitrato O, formally nitrato. Then M bond NO2, it is a nitrito N, formally nitro. Similarly, this is the isomeric complexes. Similarly, thiocyanide SCN- ion has two donor atoms, sulfur and nitrogen, but only one can be linked to the metal at a given time as M bond SCN or M bond NCS isomeric complexes. The M bond SCN, it is a thiocyanato S, formerly thiocyanato, and MnCS, M bond NCS, M attached to N, then thiocyanato N, formerly isothiocyanato, M bond NCS, metal attached to N, metal attached to S, thiocyanato S, then thiocyanato N. Other ambient ligands, Cn minus, cyano, M bond Cn, isocyano, M bond Nc, S2O3 2 minus, thiosulfato S, thiosulfato O, thiosulfato S, the metal M bonds SSO3 and thiosulfato O, metal bonds OSO2S. Bridge ligand, another class, that is a bridge ligand, bridging ligand. A monodentate ligand having more than one lone pairs of electrons, hence can attach to two or more metal atoms or ions, and thus acting as a bridge between different metal atoms is called a bridging ligand. F minus, OH minus, Cl minus, SO4 twice minus, etc. The metal, then oxygen H, then metal. M, OH, M, M1, OH, M2. Then example, palladium, then attached to bridge, that is a Cl, PD, palladium. Palladium attached to bridge Cl to PD, palladium. The flexidentate ligand, it is a polydentate ligand which can bind to a metal with different numbers of its ligand sites. For example, SO4 2 minus can function as either monodentate or a bidentate ligand. The NH3 cobalt SO4 in bracket raised to plus, SO4 2 minus as a monodentate, En2 CO cobalt SO4 in bracket raised to plus, SO4 2 minus as bidentate. EDTA is normally hexadentate ligand, but it can function as a tetradentate or a pentadentate ligand. Means it is a flexidentate ligand. Bridge ligand in which there is a palladium is attached to bridge Cl, then palladium. Palladium is attached to bridge for the Cl, two atoms, and then palladium. Bridging ligands. Then flexidentate ligands, there EDTA is a flexidentate ligands. It is normally hexadentate, but it can be function as a tetradentate or a pentadentate ligand. Thank you.